First of all, thank you very much for inviting me here and giving me a chance to present one of the developments in my lab, and that is we are trying to develop a better way to remove particulate matter from diesel exhaust. And this work would not be possible without my trusted associate, Dr. Han. So what is it that we're talking about here? Well, we all like this, right? Blue sky, nice meadows, flowers, and all of that. But however, and unfortunately, very often that gets interrupted by this. Even driving here today, I got stuck behind a diesel truck, and it's not a pretty picture. So what is being done about all these black clouds coming from exhaust of diesel trucks and cars and engines? Technologies do exist to deal with that, so-called diesel particulate filters. And what they do, they actually push the airstream through that material. It's like a very dense honeycomb, and the particles get trapped. And they do work. There are even some standards for them developed, and many trucks have them. They do work. However, as they continue operating, they fill up with particles. As they fill up with particles, these particles then have to be burned off. They have to be removed, so-called particle regeneration. As they get burned off, additional particles are generated, like in one of those studies you can see in the right bottom corner. And those particles are in the nanosize range. That is very small particles, smaller than 100 nanometers in size. And approximately about 1 trillion of them are produced per kilometer driven. So, plus, in addition to that, all these accumulated particles are creating back pressure to the engine, which reduces mileage and leads to increased emissions of greenhouse gases. So those additional small particles, is that a big deal? You know, this a couple of additional trillion particles. Well, it turns out they are, because they belong to the class of particles known as the ultrafines, that is smaller than 100 nanometers. And because they are so small, they're able to get very deep into the lung once you breathe them in. And I'm just giving you a couple of examples from studies that looked at these particles, and they all find that exposure to these particles will lead to increased mortality, increased airway obstruction. They can even penetrate into the circulatory system. And they are being found to be more potent than regular particulate matter that is currently being regulated. So these ultrafines are an issue. So I named several problems here. And I think that we can do better as far as these diesel trucks and engines go. So what are we suggesting? Well, we're suggesting to take something that is very familiar to you, that is electrostatics. In electrostatics, particles come in, they are being charged electrically, that is, you add some ions or electrons on them, they become electrically mobile, and they are exposed to electrical field and then collected on some collection surface. You probably have devices based on that somewhere in your home, or you have seen them in the stores and warehouses. But we are offering a very different approach using this old technology. We have come up with what we call a battery of screens to collect the particles. So here, particles come in, get charged, and then they enter pairs of screens. And those screens are connected alternatively to ground and to high voltage, ground and high voltage. And because it is stackable like a battery, by adding the number of these, you can increase how many of these particles are captured. Plus, we can vary parameters here to make sure that they are distributed uniformly throughout this contraption, what we call the SBEC, or electrostatic battery for emissions control. So that's one goal. Okay, it goes through here, particles are captured, and because inside we have a mesh screen that is pretty much open space, it does not create back pressure to the engine, so that would lead to improved mileage, and that would lead to reduction in greenhouse gas emissions. But that leaves another problem. Over time, the particles would still collect on the surface. So how do we deal with that in a way that does not create additional particles? Well, we looked into some interesting features in nature, especially this beautiful flower, and that led us to the legend of lotus. Lotus is a revered flower in, you can see it's a description that leads to purity, divine wisdom, and so on. What does it have to do with particle capture? Well, absolutely nothing. But what it has to do with is that lotus flower has the great ability to stay dry and clean. This is the regular leaf that's been rained on. So you can see the droplets staying like puddles on the leaf. You look at the lotus flower leaf, the droplets bead up because the surface is so-called superhydrophobic surface or non-wettable. And the reason for that is that it has very fine nanostructure, but most importantly, as the dirt accumulates, that droplet rolls down, picks up the particles very easily. So how do we get from this flower into this device? Well, that means we need some sort of substance that we can apply to our screens that could be used then to remove this collected particulate matter. So with that, we searched far and wide, and we found one substance. They sent us a sample. We applied it, worked like a charm. We asked them, give us some more. And they said, well, we don't make it anymore. So we had to find another company that makes that substance just as good. So with all that in mind, then, we can capture the particles. That will not require particle regeneration. And whatever is then removed from the screens, the carbon, then that could be reused for some other applications. All that carbon doesn't have to be thrown away. So we have actually made a prototype using 3D printing. This was one of what we call the shell type. Essentially, it is a shell. We have a number of screens. We incorporated that particle charger into this prototype with the screens of different porosity. We even tested this prototype now with one of the electrical diesel engines. I couldn't believe how dirty these engines are. It produces this concentration. If anybody is familiar, it's about 10,000 times higher than the air pollution limits that are regulated by the EPA. But the good news was, with our prototype, we saw particles that were collected with about 95% and higher efficiency, and that lasted for about 6 hours, our test, and there was virtually no pressure drop. So the air went through unimpeded, which then would lead to better engine performance and less usage of fuel and emission of greenhouse gases. So now we have already produced a larger prototype, and that will be our next steps to try and test this with actual vehicles and see how that works. Because one of the advantages of the technology we propose is that it is scalable. We can go from smaller to larger because physics and principles are the same. So what are the big advantages that we see here? By using this technology, we'll have less of greenhouse gases emitted because less of the fuel is consumed, increased mileage, no back pressure to the engine, no harmful nano-sized particles emitted because it does not require regeneration. We can capture the particles and reuse that carbon. Technology is scalable, will be less expensive because we can do 3D printing. We can do this very quickly. And plus, we have this very wide range of applications. We can start with various trucks and move on, cars and trucks, and probably move on to much larger engines such as ships and similar. So this is what we're suggesting, how to improve our health and how to improve our environment. Thank you.
Thank you very much, Dr. Mainelis.
I'll start again. Two questions, one technical and one public relations. So the technical question, is the ionization efficiency uniform over the full range of particle sizes? And then if it is, and everything's scalable and cost effective, I think the one key aspect is, how do you get governments to force the adoption of the technology? Otherwise, you'll never have a chance.
So let me start with the technical question. Particle charging does depend on particle size. It turns out the smallest particles are the hardest to charge.
Yeah.
But we have tested specifically in the lab with nano-sized particles, and even for those that are harder to charge, we have very good collection efficiency. Because with the cloud of ions that we create and the mixing that we have, it's efficient. So when we can collect those that are hardest to collect, then the collection of the larger particles is even better. As public relations go, the regulations right now are for large particles, so-called PM10s, fine particles, PM2.5. We don't have regulations for the nano-sized particles. We do, however, have a lot of literature on the ultrafine particles, into which category they fall. There is increasing concern about the engineered nanoparticles and possible health effects. That's another area to be addressed. So I think as the public awareness increases, and in combination with reduced greenhouse gas emissions, improved mileage, and overall contribution to our environment, I think that would be our selling points. Even as you know now, EPA is discussing changing the ozone limit. So they are concerned about the effects of air pollution on health.
Sure.
So if we show the advantages of the technology, I think, and if there are adopters, early adopters, and this increases, I think we could have a winner.
What would it cost to what does it cost to regenerate the current filters that you described, and what would it cost to instead, retrofit or however fit this product into someone's vehicle?
So the current installation of current technologies costs about $3,000.
That's the regeneration that you described?
The actual DPF, the actual unit.
Okay.
And then regeneration as far as power consumption, I'm not entirely sure what that
I'm
would
assuming
be.
that vehicles today come with that installed. People
And
aren't.
with that installed, all the ones could be retrofitted. Retrofits cost about $3,000, so somewhere in that neighborhood. The cost here would be less because we can make this on a scale using 3D printing and using inexpensive materials like these chargers, using carbon fibers. They are not expensive. Metal screens are not expensive. Putting them together, once that automated, it would be less expensive than current technology.
Is there applicability to non-diesel fuels?
Yeah, we chose diesel fuels because diesel fuels, compared to gasoline fuels, they produce much more particulate matter. Gasoline engines are not. They are, but not to the same extent. So if you want to, but there is research showing that yes, there is also nano-sized particles produced by regular gasoline engines. Yes, in that case, this would be applicable.
And is there a critical time period for something like this with some of the energy alternatives and solutions that are out there? Do you think that there is a timing issue in terms of launching it, getting regulatory government approval, retrofitting it, scaling it, all that kind of stuff?
I think we see a lot of development in alternative fuels, especially for passenger cars, especially I think electric is probably the hottest right now. For the large diesel trucks, I think that will not be replaced soon. We still got diesel, we still got biodiesel. Biodiesel is just as bad as far as particle emissions. So I think that constraint, if we are looking at diesel engines, is on our side. That is, we have sufficiently long time frame now, which actually is imperative to try and get this sooner rather than later so that we could minimize the health and environmental effects.
Take one more question.
What's the competitive landscape look like? You mentioned, I think I saw a patent up there.
Yes,
What are there other alternatives that do something in a different way?
There are, the patent that you saw, that's our patent. I have seen some who try to use somewhat electrostatic technology, but nobody has used a combination of electrostatics and super hydrophobic surface and specific design that we have.